Welcome everybody to our 6th class session. Today we're going to be talking about making edits to the Generic Fanuc 5x mill post and looking at a couple of things. We're going to look at where does output come from. So what are the post blocks that are responsible for generating output from the post so that we can know in general where to make edits. Then we're also going to take a look at formatting and both for changing the prefix addresses for strings and the numeric formatting portion of the variables so that we know how to change that. We did have a question that deals with can text. So what is can text? Can text, when you go into pretty much any operation in Mastercam, there will be an option called can text. And can text is a mechanism that exists at the operation level. So you create a drill op or a contour or a curve 5-axis, there will be a page for can text. And these are options that you can pass to the post processor. There are some default options that are set up and controlled using can text. Stop and op stop. So by default, these are configured for M00 for stop for can text, and op stop is configured for M01. So there's this mechanism in the post that looks for can text with a value of 1 or can text with a value of 2, and based on which one it is and the placement of it, it will then output M00 or M01. There are 3 default output places inside the post, and they're designated can text before, can text with, and can text after. Now, in general, when we say before, with, and after, we're talking about the tool change event. So if you wanted to output an MO before the tool change to this drill because you want somebody to pay attention to something, you could say, all right, I want an M00 and I'm going to do add before. Sometimes when you come into this page in the dialog box, you'll select an option in the list and you'll click the button add before, add with, whatever, and it won't actually let you add or do anything. That's a bug in the Mastercam interface itself. So when that happens, if I'm clicking on block delete on, for example, and I click add with and it doesn't put it over here, then what I'll do is I'll exit the operation that I'm working on, save it or whatever, save my Mastercam file, and then I'll do file, repair file. And this is the RAM saver command, which is what it was called prior to 2017 being released. So RAM saver, or in 2017 or 2018, repair file, and it will go through and it will refresh the Mastercam database where it stores all the data, and it will also refresh the graphics display. Now, I'd say 50% of the time I can run RAM saver like that. I can go back into the operation and it will now let me add can text. And this is a great example. So here's where a case where it's gone on the fritz. I go to op stop, I say add before, nothing happens. I say add with, nothing happens. This is a bug in the interface. So whenever that happens, close your op, save the file, shut Mastercam down. I don't know any better way to deal with that exact bug. But just, when it happens, save your file, shut it down, bring it back up, and generally when you do that, you should now be able to access those commands. How long has that been going on, man? I've noticed it pretty much throughout the Mastercam X series. I don't think I noticed it back in the version 9 days. So 15, 20 years. But if you don't know about it, it's, you know, it can throw off your whole day, because then you're like, oh, what do I do? You know, this thing won't work. And the reality is, it's just the can text function works fine. It's the Mastercam screen interface that's getting messed up. Have they tried to fix it? I'm not even sure if they're aware of it, to be honest. I mean, I've seen other people complain about it. You know, the reality is, I just don't have time to be CNC Software's quality control. So there's a whole bunch of stuff that I could go report and, you know, put in a software enhancement request or bug fixes or what have you. But man, I'm busy. I'm busy doing posts and training and all kinds of other stuff. So I know that when you come back in here, you'll now be able to, and you know, sometimes when you do report something and you do finally get an enhancement request number, there's two things. One, all of the requests they get are weighed against how many people are complaining about that issue. And if you've got an issue where 20 different people have reported it, and everybody's piling on and complaining about it, they fix those things first. If only one or two people have sent it in and you've got a bug number, it's kind of like, sorry, Charlie, you're at the bottom of the list. So once you do restart Mastercam, it should start working for you. Before, with, and after the tool change is the general placement of can text before, can text with, and can text after. However, the can text mechanism was constructed with the ability to be customized in mind. So they want you to be able to use this can text where you need it. So in the post, there are 3 different sections that gather the settings. Pcan, Pcan 1, which is with. So Pcan is before. Pcan is before the output call. Pcan 1 is with, can text with the move. And Pcan 2 is the after. Now, in general, Pcan, P-C-A-N, and Pcan 2 can be used to output entire strings. If we go down and look at the end of the output here at Pcan 2, you can see that we start with the string can text. So this is a variable that gets constantly overwritten with new strings. And we set it to equal nothing. We set it to an empty string. String can text equals S blank. Then we check the value of the can text number, and based on if it is 2 or 5, we end up calling one of these blocks right here. These guys, Pcan text, or Pcan 1 through Pcant 20, end up setting the string can text string. So you can see what ends up happening. Like, let's look at Pcan text 1. The user-defined variable can text position is set from the predefined variable can text position 1. The can text string is set from the can text value. So when we look at can text being output, let's do this. I'm going to do stop, add before. I'm going to do block delete on, add after. And this is operation number 3. In operation number 4, I'm going to do block delete off, add before. Oh, look at that. So save it. Try to run RAM saver. Ooh. Block delete off. Add before. Okay, so I did run RAM saver. I came back in here. It let me do it. It's just flaky, man. Sometimes it works, sometimes it doesn't. So now I'm going to take op2, op3, op4, and op5. And I'm going to post them. Ooh, what did I do to the post? Did something. First of all, let's do this. Oh, so what I've got is I've set the default for my string select. No, what? So what happened was inside the post, we have set a default for the reference return. Reference return is normally 0 for G28 or 1 for G30, and I've set it to a value of 2. So what ends up happening is this SG28 ref call uses MI3 to pick which string is output, and I've got it set wrong. So I want to add another string here, and because I added a string, I have to change the number of strings in the string table. And now when I post this again, so the reality is I would have gotten the error message regardless of whether I did block delete or not. When we look at the output, I've got an operation here, which is my drill or yeah, it is a drill op. So that's the entire operation that's been output. Then we get our next operation in the list. If I go down, minimize this a little bit, you can see it better. So here's the drill and counter bore. Here's the contour, and it's on the back plane. And what you see is that we've got the MOO that happened before the tool change. We have the tool change, we have the first position move of the tool change, and we have our G43 line. So we've gotten the tool into position at Z6.2, and now we've got block delete turned on. So we have the opportunity in this case to skip all of this. Now maybe we've got T256 here, this is T241. So maybe we actually want to skip this whole thing here. In that case, I'd go back into op3 and I would say block delete on, add before, and I like to do before, with, and after, honestly, just to make sure it's on. I mean, we can probably remove these. But we now grab those ops again, repost them, and we're able to essentially skip the entire operation if we throw the block delete switch on the machine.
if we did it at the with stage instead of at before. If I go block delete on add with, ooh, of course, say okay, and maybe it's just going out and coming back into the operation. I can't remember what the trick was. Yeah, I'm gonna run RAM saver. Yeah, it's just one of those things where it gets a little annoying. Okay, add with, and remember I turned it off on op 4, and that's the key there. If I only want to skip one operation, I have to turn it on with op 3 or whatever op it is, and then the very next one you have to turn it off, otherwise it remains on. So post these out again. Now this is block delete with, and you can see it changes just slightly, because if I do block delete with instead of before, we skipped the tool change. So now it actually changes to this tool, but if you've got block delete on, you're going to skip all this code anyway, so what's the point? If that were the case, I would put block delete on before the tool change. But what does this look like? Oh, let's do this too. Let's do stop, add before. We're going to do block delete on, add before. And let's do op stop. Oh, no. I'm going to leave those on there. I'm going to go into the other one down here. And I'm going to do block delete off, add before. And I'm going to do MOO, add before. So I'm going to take all 5 of these operations and post them. But instead of posting the NC file, I'm going to post the NCI, which is the intermediate toolpath data. And this is what the post digests and spits out your code with. So in the first operation, there's nothing in the can text line. So this is the NCI G code for our drill op. Then we get down to the second operation in the NCI, which is op 3 in our toolpath manager, and you can see that we've got can text position 1 here with a value of 1, can text position 2 with a value of 3. Then in the next stop after that, can text position 1 value of 4, can text position 2 value of 1. And down to the next one, and we're back to zeros. Oh, no worries at all, Nick. Boarding up the windows, man. That sounds like oh. What's going on? Oh, let me get this guy here. Let's go apply. Copy link. Oh, that sounds gnarly, man. Well, yeah. Well, hopefully everybody's gonna be safe and no damage occurs, man. I wish you guys the best. That sucks. Oof, man. 20-30 inches of rain. Wow. Okay, so getting back to this guy, we fixed this. One of the errors that we had was that we had a setting of 2 for MI3, and there was nothing to select. Now, we've set it to use G53 output, but the problem with the G53 is that you've got to use absolute coordinates with it, and you always have to call out, it's non-modal, so you always have to call it out. So we would have to do just a little bit more work here. Down in P retract, So P retract controls the end of the toolpath for the tool change event. And we have some output that occurs here at the end. So we turn off the coolant if it's been turned on. We turn off the cutter comp and the spindle if they've been turned on. How do we do that? We've got some string select variables that are on these lines, and this is where the output occurs from. We can tell it's an output line because it's got PBLD and $, which is our sequence number, and all of the output statements are separated by commas. Finally, it ends in $, which is the carriage return line feed character or variable. Now, up above here is where we actually turn everything off. Coolant we set to 0. CC pause we set to 0. G code we set to 0. Spindle direction we set to 1, which actually, if you look at the string select table, turns on M5. So there's a special variable that is used to control whether we get clockwise rotation off or counterclockwise rotation, and it's SPDIR2. So we set these variables to 0, and then down here is where we output the spindle off stuff. Then we have pref return. And pref return is what gives us our G0, G28, G90 or 91, and then Z0. So unfortunately, the way that this is built by default, it just uses SG28. And what we really want is the SG28 ref, because this guy is part of the string select table. And if we go and look, set a bookmark here. If we look for SG28 ref, you can see that it's the target string of this string select table, and it's also right here. So what happens is we look and see SG28 ref on the output line. At that point, our string select function gets invoked, and it looks at the value of MI3, and based on the value of MI3, we are going to look up a string from a string list that starts with SG28. So the string list starts here with SG28, and the string list is 3 strings long. So we have SG28, we have SG30, and we have SG53 as part of this string select table. And based on the value of MI3, we are going to load one of these strings into this variable, and then we're going to output it. So that's where the output occurs. Now we also have another situation here, because we've got SG code, which is going to output our G00 because it's forced. We've got our G53 coming out. Then we've got SG absync, and it's also forced. But we don't know what the value of SG absync is going to output. That's going to depend on the value of absync here. So you notice we set absync to 1, then we call pref return. Because absync is 1, when we output absync here, it's going to output a G91. So what we need to do is manipulate this line of code where we're setting the selector variable. So if we go look at SG absync, you'll notice there's a bunch of places where it's included as part of output. And it looks up its value from this string select table. So we're either going to output G90 or G91, with the SG absync variable. And the variable that controls the output is a numeric variable called absync. So what we'll do here we're going to say if mi3 equals 2, absync equals 0. And then we're going to put the else condition in front of absync equals 1. And therefore, if this is true, so if mi3 equals 2, we're going to set absync to 0. Else, in other words, if mi3 is anything except 2, then we're going to set absync to 1. And we're doing this so that we don't break this logic down here. So a lot of people will just go and, take this variable out and put in a string literal. And you could do that, but now the post doesn't know that we're in G90 mode because there is actually a mechanism called a string select table that keeps track and outputs G90 or G91 only when the value changes. Okay, so we've done that. We're going to save that. And if we repost the NC, and we go up to the top, so it looks like we've got a place where G91 is forced or called out as a literal instead of as part of the string select table in either PSOF or somewhere in P header, but it's most likely PSOF. If we look at the end, we are getting GO, G53, G90, Z0. So we can go look in PSOF. So here's PSOF. Custom changes allowed below. And you can see here we're getting our G20, G21, and our safety line. So let's shrink this down just a bit. Okay, and that would be these two lines right here. Then you can see we do save absync equals absync, absync equals 1, pref return. And that's what's giving us these two lines right here. So once again, we need to do our if mi3 equals 2, and in this case I'm using the constant variable TWO, so because it's already predefined up at it's already defined up at the top of my post here. So if mi3 equals 2, absync equals 1, or absync equals 0, else absync equals 1. And we repost. Okay, and now we're in absolute mode. If we wanted to change the formatting for our G00 and our G1 and our G3, that is also done in the string select table.
So string select tables are used for a lot of our output. Starting here with general G and M code string select tables, you'll notice that we have our motion G code select. As part of the motion G code select table, we also can output dwell G4 with the 5th string in the list. When we build a string select table, we take a list of strings that has an order to it. So this list goes from top to bottom, and the very first string in the list is item 0. So we actually start counting with a 0-based index. When G code $ is 0, we look up the first string in the list. When G code $ is 1, we look up the second string in the list, which happens to be G1. When this is 2, we look up that one, which is the third string. And when this is 3, we grab the 4th string. Okay, so it's a 0-based index. G code $ is the selector variable. It's the numeric variable that changes and pulls these values from the list. And this gets its value from the NCI data as the NCI data is processing. And the same thing does happen here with selecting the work planes. So work offsets is a little different. Work offsets has a different functionality. It's not actually a string select table, but you can see that the work plane is, so plane _2 controls whether we get G17, G19, and G18. Oh, yeah. Yes, it is 0-based, same as the work offset setting in the dialog. Correct, absolutely. English and metric, G20 versus G21. So you'll notice I've modified the reference return string select table to include a third value for G53. Cutter comp is part of a string select table. So SCC comp, it's going to look up a string. It's going to grab either G40, G41, or G42 based on the value of CC out. Now, a lot of these you'll probably won't change. Most of the time you're not going to be changing G40, G41, or G42. We'll use those as a mechanism as they exist, because it drives our output already the way we want. Sometimes you may want to do this, just based on what your machine requires. Some will require it to be a 2-digit code. Most will read either, so either a 2-digit or a single digit. I like to do the double digit like this because I like the spacing. Because a lot of the other codes that are also on these lines are also 2-digit G codes. So I just like that look better. So we'll do that. One of the ones you will often change is the value of the drill cycles for the string select. So here you can see drill with dwell, or drill with no dwell, in this case is a G81. Drill with dwell is a G82. Yeah, our old Fadals don't have enough memory to give me the luxury of extra characters. I hear you, feel you on that. Peck drill G83, chip break G73, tap G84 for right, and G74 for left.
Maybe your machine doesn't differentiate between left and right hand tapping, so it's G84 and G84, and then it's just whether you have an MO3 or an MO4 that tells it, this is a left hand or a right hand. Boring cycles, maybe changing some of these G codes here. So maybe your machine, uses, if it's a dwell on a G83, maybe it's a G83.2 or something like that. You can change the string output here. G90 and G91, also a string select. Feed mode. You'll notice that we have a string select here for units per minute, so either millimeters or inches per minute with G94, or inverse time for G93. Sometimes it's necessary to go in here and add a code for degrees per minute, or feed per revolution. So sometimes instead of G94 you might want G95, and if that's the case, then we need to expand this string select table. So feed per rev, and we would change this to 3. In general, add after. What do you mean, Nick? For adding extra strings in the list? Definitely. If you're going to add extra strings, add them after the last string and then change this value here. Because most of the time, there is a mechanism that already exists that is setting, for example, IPR type. And the other thing is when you add another string to a string list like this, IPR type for this string select table is the selector variable, which means when we are switching modes, we don't modify this. We modify this. So if we search for this one, if we search for IPR type, here you can see in movement output, NC output, if IPR type, right? We're setting feed equals feed rate inverse, else feed equals degrees per minute. So we keep looking. So it looks like IPR type is being manipulated in the PSB file. So this may be something where we need to add some extra code to handle it just before output. Because a lot of the times, if IPR type, for example, is being set internally inside the PSB file, we don't have access to go in and change those values. But all of the output from our post occurs from the PST. So there's always a way to go about overwriting. It's just where do you go do it? Typically, for motion, you're going to be outputting rapid from P rapid out. You're going to be outputting linear from P lin out. And you're going to be outputting circular from P cir out. So this would be where I would go to modify my IPR type to be able to, choose the G95 instead of the G94 with this SG feed variable. So if we went in here and said, if maybe I'm using MR3 for this, or MR4. So this would select feed per revolution. Yeah, or make a quick post block and call it from each of them. Yeah, so you could say like this.
Okay, PFPR, feed per revolution. And we could say if MR4 equals 1, IPR type equals 2. So now all I have to do is call PFPR, and I'll do that here. And we'll do it here. And we'll do it here. So that'd be another way to handle that. Now we just have to remember that we used MR4 for selecting feed per revolution mode, if you will. The other place to do this, because we're doing it with an MR4 variable, the problem is when we look at the output from the operation, let me do this. We're going to go into the drill operation. We're going to go look at our MISC values, and we want to use MISC Real 4. So if we want to use MISC Real 4 in order to switch over to feed per revolution, then we can activate it here. The other issue though is that when we assign a feed rate value, we either have to remember to enter it like this as the actual feed per revolution, or whatever you want it to be, right? But the problem is then we get a feed per tooth calculation for 0 and it just screws everything up. So it's better in some ways to say, all right, I want to do a feed rate of 10 thousandths per revolution, and I'm going to multiply that by my spindle speed. So 8,556. So that's going to be my feed rate. But in my MISC values, now I'm going to turn on, feed per revolution output. So in order to make that work, not only do we have to set our IPR type to 2, because we're now going to output G95, we also have to correct the feed value. Because if we go look at our drill output, for example, here's where we do all our normal pre-drilling output calculations to set all of our string select values. And then here's where we actually output the code for our drill. And here's where we're getting our feed. So we want to do this in the smart way. We're always going to call P common drill B before each of the predefined drill cycle blocks. So up inside P common drill B, we're going to do this. So PFPR is going to check the value of MR4, and based on the value of MR4, we're going to set IPR type. We also need to worry about this feed variable. Yeah, that's exactly what I was going to get to. So we need to worry about this feed equals FR pause. Now another way to do this is to do this. If we we include it in an if statement and we say if basically if MR4 is not 0, that's what this statement means. So if MR4 with a comma means if MR4 is not 0, we're going to call PFPR. And we're going to do else feed equals feed rate positive. Because we're relying on MR4 as the trigger to both call this or call the feed, we need to make sure we set the feed value properly in PFPR. So let's look for that. So we know we're in feed per revolution. So we can do feed rate positive, or feed equals feed rate positive divided by the spindle speed to give us our feed per rev value. We just have to remember to set the feed rate to be, the inch per minute equivalent of the feed per revolution value that we want. So we do that. We have a value for MISC reel 4. While we're at it, we go down here to our control mill for the OKK. We're going to go look at MISC reels. We're going to put in a 4, and we're going to call this okay, so feed per rev. We're going to save that. Oh, I forgot to close the string, and we need default values. So I'm going to set it to default to 0 for both inch and metric. Then we're going to go up to our defaults, and we're going to paste that in. So if we repost the drill op, let's see what we got. Close that. Ooh. Let's redo this. Let's go post it. Let's see what our error is. The error is occurring on line 1391 in the post. So let's see what I did. Label has not been defined, so I must have spelled something wrong. So if we go back and we look at, it's IPRTYPE. So that's it. That was my mistake. Spelling error. So we'll close that. And we'll post this. And we're getting the feed output. Do you need brackets in the post block? No, you don't need brackets in the post block here. The only time you need brackets is when you have a Boolean statement. The then is the comma. So we have a condition here. We have if this condition and this condition are both true, then do something. And normally you can only do one line of output, or you can do one action after the then. The reason you put the brackets in is if you have multiple things that you want to happen when the result of your Boolean if condition is true, you want multiple things to happen. So here we've got, our IPR type stuff here. Yeah, it will output it every time, so it would be good to actually no, the modality should not it output every time. We do need to go to pdrill. Drill ref. We've got the R position, but we don't have SG feed. So we need the string select for SG feed. Because now up in pdrill common B, we will be calling PFPR when MR4 is 1. And then that way we're going to set the feed rate, and we're also going to set the SG feed variable value. So we add that to the output line, and let's post it again. And now we're getting our G95. And the proof is always what happens if we turn it off. Do we get regular output again? Anytime you make a change to the MISC values, you need to make sure you regenerate the operation. You're going to have to force a regeneration to make sure the change sticks. And now we get a G94 and the feed rate value that we programmed in the operation dialog. Yeah, no, unfortunately, not only does it not dirty the operation, but unless you regenerate them, it doesn't stick. So you can change it here, and you go back in the operation, and it looks like the value's set, but it didn't actually get written to the NCI data. Yeah, it's annoying, to say the least. I've just always gotten the habit, whenever I make a change, regenerate. Just regenerate every time. Yeah, 85 inches a minute for a drilling op, it's only, well, I should say this. It's only that fast because we're trying to do, 80
or 8,000 RPM. And, 10 thou per rev for a drill is really not that bad. It's just, how fast are you spinning the thing? Nice, 180. Yeah, I've definitely gone in the hundreds, probably 100, 120 for feed rate. But a lot of times that's aluminum, so you can just slam it right through. There's a huge difference between that and tool steel, So, getting back to the post here. We would need to make sure, if we wanted to be able to use feed per rev in other cycles, that we also included the SG feed. And maybe we want to move this after the actual drill cycle itself. So let's do SG feed there. And we'll put it there, and we'll put it in the chip brake, and we'll put it in the tap. Oh, I'm sure, why not all of these two? And the only thing we want to do is up here in P drill, I'm going to search for SG feed, because we just want to be sure it doesn't occur more than once in each block section here. Yes, moving these output statements around on the output line absolutely changes where it occurs from. So here we were getting the feed in inch per minute or feed in inch per revolution here. Now we want to move it after the SG absync, which is, SG drill ref is G98, G99. We're not actually getting any abs inc output. So I would take this, let's move it after this guy right here, actually after PR drill out. So I'm going to move this guy. Let's move them after the R drill out. But yeah, each one of these output statements is either a variable that's going to output, a part of a string select table that may or may not output. Oh yeah. So if we, if we wanted to move this line over here, absolutely. Yeah, you can highlight and drag the text around. It's pretty sweet. So, so I moved SG feed after PR drill out, and now we repost. Oh, there's the R drill out. So really, I moved it one too far. So SG drill ref. Yeah, so here's the R drill out, which is actually going to output X, Y, Z, the rotaries, and the reference. So moved it one block too far. There, I'll just move those two so you can see it. And repost. There we are. So now we're getting G81, G99, G94, and we're getting our feed rate here. Maybe we want, 3,500 and you know, it's 0.008 per rev. It's 3,500, 28 inches a minute. Regen, repost. Oh, we're going to say yes, everything's okay, and what do we get? Okay, so 28 inches a minute and IPR, and or inches, that's inches per minute, and if we want IPR, now we turn that on, regen, repost, and now it's in inches per rev, and we're getting a feed of 0.01. Ah, now here's a great lesson. What should our feed rate be? What did I enter into the box? 0.008. Good. Somebody was paying attention. 0.008 times 3,500 gave me 28 inches a minute. Why am I getting f.01? Yes, rounding. So what's going on here in the post is that I have a format value that is assigned to my feed variable. So when I go look at the top of the post and I search for feed as a variable name, eventually we'll get to it. Unfortunately, the word feed is used in a lot of things. Here is where we have the assigned feed rate, or the assigned formatting for the feed variable. The way the FMT statement works, there are a list of format statements typically up above the FMT lines. And the format statements tell the Mastercam post how to format the numeric portion of the variables. By default, all of the calculations inside the post and all of the variables that aren't assigned a format for output are assigned format statement number 1. So you'll notice for English or inch values, we are automatically formatting them with 8 decimal places. And for metric values, we are formatting them with 7 decimal places. Now for output, typically format statement number 2 is going to be 4 place for inch, 3 place for metric, and this is what gets used for almost all of our standard positioning output. Format statement 4 gets used typically for integers. Now you can see format statement 15 is what we're using for this feed value. Now in general, you're going to want to use and set the values for your variables based on what your machine manual tells you is the actual formatting for the feed. If your machine will take up to a 4 decimal place feed value, well, there's no reason that you can't go back up here and say, oh, decimal, absolute 4 place, that's format statement number 12. And meaning it will round at 4. If it's less than 4, it's not going to add extra zeros, but it will allow you to go up to 4 decimal places. You notice we also have one for 5 here. So we could potentially just change the value here. But we run into an issue. I'm formatting for feed per revolution. And sometimes on the control will actually say, for normal, inch per minute or millimeter per minute output, we allow 3 decimal places for feed. Okay, so maybe we want to go up here, or let's say that they don't. Let's say they allow only 1 decimal place for feed. If we look through the numbers that are listed in this column, we're looking to see other variable assignments, format assignments, that have 15. And what I can see by scrolling through this list is that no other variables are assigned format statement 15, which means that I should be able to edit format statement number 15 and use that as necessary. So if my real machine would allow me to take 3 decimal places, maybe it's 3 decimal places for inch and 2 decimal places for metric. So we'll make this 3 and 2. Save that. And if I output it now, everything's fine. Because I get my 3 decimal places and I'm a happy camper, right? But what about this? What if I go in there and I say, you know what? I'm going to spin it at 3357. And I really want 8.5 thou per rev. 0.0085 times 3357. And I'm getting 28.5345. Okay? And I post it, and maybe this is okay for drilling. But what about if I'm doing this as feed per rev for tapping? Well, I go and I look in my manual and it says, oh, well, when we're in feed per revolution, we don't use an F value. We use an E value, and it takes up to 7 decimal places. Okay. Well, I could go in here and I could say, all right, I'm going to make this 7, right? I'm not going to right now, but I could make it 7. And I could go down here and I could change this F value to an E. But that would screw up all of my regular G94 output. So Mastercam MP language gives us some functions to allow us to change the prefix character and the format statement that is assigned, the format statement number, on the fly. So in the post block, we can switch the format statement and the prefix, and then we can switch them back. So what we'll do up here, we're going to create a new format statement. They say in the documentation you can only go up to 30, but it's a lie. I think you can do hundreds of them. We're going to do this format statement 2, and I'm going to call it 77 because we're going to do 7 decimal places. Decimal 7 place. Can I call this FPR?
And we're going to go into PFPR. And we're going to do some work to assign the feed variable with some new formatting. Now, in order to really pull this off successfully, we're going to go back up to the string definition for strings, just the regular standard strings. And here in the address string definition, you can see that we've got kind of some standard string variables that have been created to match the default letter of the alphabet. So like stri is set to the string I. strj is set to the string j, for example. This is what we used for a long time. When we needed new strings, we just added them. If I needed E, I would type in STRE, and I would make my E string. Now, we actually have some predefined strings. Ooh, I know what I'll do here. Turn off everything except the string definitions. We actually have some predefined strings that we can use if we just want to pull a single alpha character out instead of having to define our own. So I can use S_F_PRE for the string for the prefix character F, and I can use S_E_PRE$ for the E character. So that's a new thing. So that's what we're going to do. We're going to go PFPR, and we're going to do, so basically, if MR4 is 1, we're doing the IPR type set to 2. We're calculating our feed rate value here. Now we need to assign the new prefix string. So we need to do this as part of a formula. Typically we use a user-defined variable called result. And there is trying to trying to do it without the thing popping up. There we go. Oh, come on. Okay, you can see it right there. It's new address. So return equals new address. And then you have the prefix string variable followed by the variable you want to assign it to. NW ADRS. Ooh. So NW ADRS, and then it's S_E pre, which is the E prefix, and I want to assign that to the feed variable. The other one I want to use is new FS, which is the new format statement. So format statement I'm going to assign is 77, and I'm going to assign that to the feed variable as well. Okay, now doing this is great. But the issue is that if I assign it this E prefix and the format statement of 77, I also need to set everything back when I'm done. So if I look at where PFPR is called, I'm going to take it out of P rapid out, P lin out, and P sur out, because I was just showing that kind of as an example. Right now, we're using it in P drill common B. So what we're going to do here, we're saying if MR4, we're going to call PFPR. Else, before I only had one condition. I only had one thing that I wanted to change. Now, I want to do two things. I want to set feed equal to FR pause, and I also want to do result equals NW ADRS S underscore F pre, which is the prefix F, and I want to assign that to feed. And result equals new FS, and it's format statement 15 for feed. So basically, if I call PFPR, I'm assigning a new string and a new rounding to the feed variable. Else, I'm setting it all back to what it was originally. You know, we could possibly add another if statement inside the PFPR, but we can also handle this since we're only calling this in one place anyway. It's probably easier just to do it here. Since P common drill B gets called before each drill cycle, this is going to work for every drill cycle. And basically, if MR4 is turned on, we're going to call this. Else, we're going to just make sure everything is set how it originally was. And so now, we're getting our E of, 0.0085. Yeah, it could very well be. Don't know if there's a way to get this to be more than 4 decimal places here in this dialog. I think you actually have to go set the toolpath precision. So toolpath tolerance. So if I do that, will it round it? Oh, good. So it will take it. So if I change that just a little bit, now what we want to see is, looks like it's going to the 4 decimal places. So that being the case, because the feed rate that we enter in the dialog is already rounded, we'd have to get a little bit tricky in order to do that. So for example, right now we're just putting in 1. Well, instead of 1, let's put in the actual feed per revolution value we want. So it rounds it off to 6 places. Yeah, at least we can get up to 6. So we'll say okay, we'll regen. And if we go look here, this
can't be 1, but we say if MR4, so if it's any non-zero value, IPR type equals 2. And we make feed equal to MR4. So now if I post it again, that looks better. Okay, feed out to 6 decimal places. Because we're in inch per rev. And if we set this back to 0, then we should get whatever we've typed in the box rounded to our standard rounding. So now we post it again. We get G94, we get the F value, and it's rounded to 3 places because that's the rounding that we've put on the feed variable as the default. If I wanted it rounded to 2 places, I could do that as well. I just need to go .15. And so if I change the rounding here, and we repost, now instead of 3 decimal places, we get 2. Okay. We've gone a little long versus our normal session. Usually we split it about the hour mark. That's okay. I've actually got to get... so we're normally scheduled to go from 7:30 to 9:30, and we take a little break in between. I've been extending class a little bit so that we can still take our full 15-minute break and not stay too, and stay a little extra late afterwards to make sure we get in enough time to cover everything. Tonight I actually have to get running right at 9:30, which is the normal end of class. So being that it's 9 o'clock, why don't we open it up for some questions, and we'll spend the next 10 or 15 minutes or so taking questions, going through anything you guys want to in the next 10 or 15 minutes, and then we'll wrap up class a little early tonight and just record basically this one session for today. So let's open it up for some questions. Oh yeah, you know what? Let's do that. Let's go ahead and take a 5-minute break. I'll split it anyway.